Okay, so this will be the last part of this lecture, and actually will be the last part of this chapter as well. It's a very quick chapter. So the main thing, we'll look at one example, and we'll show all three methods how we can utilize them. So the system looks like this. If G1 enters a signing junction, we'll draw the intermediate ones later. G2, another junction, and G3, and then G4, and goes to the output. Okay, so it has three loops. One loop goes back like this from the output. Now I don't have any intermediate blocks there. If no block, that means the transfer function back is equal to 1. So the output here is directly fed back to this signing junction. That's the first loop. Second loop come out from the G2 and goes back to the input. And the third one goes on top. It's also plus minus. Okay. Comes from the output of G3. So this is the system. Okay, the system. Okay. Now again, we can use various methods to calculate it. Okay. So what will be the most convenient thing to do? The most convenient way to look at it is to use the Mason's rule, apparently. But since we have this intermediate signal thing, maybe we use the intermediate signal as our method number 1. If you use method number 1, how do we calculate it? So this is R of S is my Y. Right, so here apparently I know this has to be Y over G4. Okay, this come back as Y, and this has to be what? This has to be Y over G3, G4, right? If I go backwards one more time. And then if this is Y over G4, come back, this will be 1 Y over G4. Okay. And what else do I know? So I can also figure out this one, right? I have this one minus Y equal to this. So the output of G2 should be Y plus Y over G3, G4. So that this one minus Y will give me that. And here again, if we know this, we'll go backward one more time. So the signal here will be Y over G2 plus Y over G2, G3, and G4. Same idea. If I figure this out, then the output of G1 will be the sum of the two, right? So that will be so that will be the sum of the two. So it'll be Y over 1 over G4. So that's the top one, plus 1 over G2. This G2, G3, and G4. Okay, so this is the signal at the output of G1. And the output of G1 will be R minus, and this signal routed back, so it'll be G3, G4. So I figured all the intermediate signal. Now the input to G1 is R minus Y plus Y over G3, G4. This is the input to the G1 block. So times the transfer G4 plus 1 over G2 plus 1 over G2, G3, and G4. So this is what we basically have. If you want to do this cleaner, of course you want to do this cleaner. So again, you put everything with R on one side, everything with Y on. We'll have what? We'll have Y times, and we have this thing, right? Then we can put everything together. So G2, that I have G2, G3 plus G3, G4 plus 1. So that's G3, G4 over G2, G3, G4. 1 over G4 is G2, G3 over G2, G3, G4. So that's one side. I move the other side over. So plus G1 over G3, G4. Okay, easy. So G1 times, I put R on the right hand side as usual. And, right, if you feel this to complex, multiply G2, G3, G4 on both sides of this equation, and I will have Y1 plus 4 and plus G2, sorry, G1, G2, G3, G4, and plus G1, G2 equal to G1, G2, G3, G4. Equation, and then you organize the terms. And I'll organize it such that we can see this from the Mason's rule as well. What is the direct path gain? Direct path G1, G2, G3, G4. That's what we have in. And if you look at this particular system, this is the only direct path you can go. If I follow the directions from R to Y without repeating, without backtracking, this is the unique way. We have 1 minus all the loop gain, right? What are the loops we have? We have the loops. We have 3 loops. First loop here, G1, G2 coming back with an here. That's 1 minus the gain of the first loop. The other loop I have here, G3, G4 coming back with a negative sign. So it will be minus, minus giving plus. Right? And then the other loop I have here, so G2, G3 coming back with a negative sign. So minus. Now for the simplified version, we should stop here, but this is not a simplified version because some of the loops are touching, some of the loops are not touching. Right? You have shared blocks with the other loops, but the G1, G2 loop and the G3, G4 loop are not touching. If they're non-touching, Mason's rule right here. That's this term we're looking at. We have to plus the product of all pairs of non-touching loops. So that means, and for the system, we have to do a plus the loop gain of there's 2 non-touching minus G1, G2. The other have loop gain of minus G2, G3. Minus minus becomes positive, and then G3, G4 happens to be the last term in the previous step. So if we follow the Mason's clearly and accurately, we must be able to that case, this is your only direct path. Okay. Loop gains. So we, of course, let me put the minus sign because all of them are negative numbers. And then this is non-touching loops. Okay. We have to add that. So method number 1 and method number 2 actually matches. Can we do method number 3 on this? Yeah, we can also do that. But to do, we have to do a little bit of manipulation. First of all, what I would like to do is I want to move the branch here and move side, so we can have something similar. We have one inner loop and one outer loop. And secondly, what I would like to do is I want to move this branch here to the outside. And not to this side, I actually want to move it even further to the other part. And if that's going to be done, this is what you will eventually have. I'll give the structure without going into the steps. This is the G1, G2 loop as before. It's not affected. Okay, and you have and then for the loop on top and moving this direction, this branch to the Y position, and by doing that, if I move it here, right, I'll draw it downward. So 1 over G4 is going to be the additional block. And then before it all goes all the way to the output of G1, and if before you do this 1 over G4, and when you do this from the output of a block to, you move it to the input of the block, of a block, you have to add additional 1. Make this correction. Before is used to enter after G1, now it's before G1. But since it's a summing junction, doesn't really matter what you add this earlier or later, so we're going to add it earlier with the reference. This is what we have. And now if we arrange the blocks like this, then we should have one is the G1, G2 block. And of course, you can also combine these three. Okay, for each subblock, you can find the transfer function. Then you have only one outer block at the end. Okay, you can use this one to be still the same. So these are the three methods that you can utilize. But as I mentioned, Mason's rule is apparently the easiest way, requires the least. The key thing is you must be able to identify all the direct paths, calculate the gains directly, identify all the loops, figuring out which pair of them, quadruple of them, are touching or non-touching, so that you can calculate the transfer function correctly using the general form of the Mason's rule above. Now, if you decide to use the simplified version, you have to make sure you only have one direct path. All loops are touching, and all loops touch the direct path. If these three conditions, if one of them is violated, you are not able to use the simplified version. Right? So this is the calculation. Now, before the end, we conclude this chapter, there is one additional concept that I want to very quickly, very briefly touch upon. This is called the signal flow graph. This is also in the title of this chapter. So this is what we call the signal flow graph. This is another graphical way to represent the system. And it's just, you know, another way to draw the block diagram. That's why I don't want to spend too much time on that. But I want to point this out so that you will be able to read a signal graph and be able to convert that into the block diagram, which is, in my opinion, more straightforward. But signal graph, you know, the footprint of a signal graph is usually lighter compared to a block diagram because you don't have blocks. In the signal flow graph, you only have two things. One is called a node. Okay. Graphically, represented by a small circle, and each node represents a signal. Okay. So in the block diagram, each block represents a system. Now, we use node, there's a small circle, as I mentioned, footprint will be lighter. So it represents a system, and then we'll have branches. Okay, will be directed arrow, and each branch represents the transfer function block. And we usually, you know, a weight to the branch to indicate that transfer function. So for the system we discussed, if we want to convert this into the block diagram, this is what we usually do. We start from our reference input. Draw this a little bit down. Right, and then the first is our G1, G2 block. There's a summing junction that will create this, and it's the sum of the difference between R1 and something that will come back in. Is through a negative sign, and we'll take care of the negative sign later. But from R1 to the intermediate signal is just 1, meaning R1. And then minus thing, as I mentioned, we'll worry about it later, but this will go to G1 block to draw this a little bit better. So this is my the output of G1. Okay. Now the output G1 will be again combined with another something, a branch there, and then this will be the input of G2, so this will be G2 here, and the output of G2 will be utilized to complete the loop, and the loop will have weight -1, so meaning the loop come back, and then the input of G1 here will be R minus the output of G2. Similarly, if we go straight, this is the output of G1, output of G2, and then this is the input of G3. So this is my G3. Output of G3 will be used to come back and calculate. So this is what we have. So input of G2, go up. Input of G2 is the output of G1 times 1 negative 1 times the output of G3. So this is what we have. And finally, so this is 1. You have the G4 block. Apparently this is your output, the eventual output of already, right? And this will be used for the G loop with a negative sign. So every time there's a merge in the signal flow graph, it represents the summation, simple summation, the sum of the signals coming into that. Okay? And if you want, subtract one from the other, what you need to do is put this negative 1 as the weight of that branch coming back. We can say this is y of s, and sometimes we want to be a little bit cleaner, so we put 1 here and reach out to this y. Okay, reach out to this y. So this is another version to represent the same block diagram we have above. And you can argue that this is a more compact representation of the system, if you would. And this is commonly used in literatures, in textbooks, in applications. But block diagram senses, in many cases, will be more straightforward. But if you're into, let's say, graph theory, this is a simple graph representation, as you can see. And you can still apply Mason's rule based on the signal graph, right? You have the direct pass, apparently from R to Y. This is your direct pass. And you can still identify all the loops. Okay, so the loops, one loop here, G3, G4 loop here, and then one loop here. You can calculate the loop gain by multiplying all the weights in the branches involved in each loop, and you can determine whether or not the two loops are touching or non-touching. Apparently it's very easy to see. If they share a branch, then they're touching. If they don't share any branches, they have no branches in common, then they are not touching. And you can apply the Mason's rule naturally to this system. Okay. So this is the signal flow diagram, signal flow graph, and we discussed the block diagram, how to use the Mason's rule, the 3 methods. Do you have a few homework questions to apply these methods? And as I mentioned, the most straightforward way is to do the Mason's rule. Okay, so this is the end of chapter 5, in fact, actually. Starting next week, we'll discuss the new chapter, chapter 6, stability. But I also want to let you know and also remind you that the midterm exam will come up, it will be held on the 16th, Tuesday. So it's a little bit over 1 week. And the coverage will be from the beginning of the class to the end of this very lecture, meaning up to the end of the block diagram, algebra, the Mason's rule. And I'll compile a document, the study guide document, outlining the coverages points, what the points are important in the lecture notes and also in the textbook, so that will help. Hopefully that will help you prepare for the upcoming exam. Okay, so I'll upload this on both HuskCT and also on YouTube, so that you can view them at any time of your convenience. Okay, so I'll see you in class next Tuesday.